Alrighty guys, one last thing to go for this particular unit. We are going to be looking at precipitation. Now remember, precipitation is what happens when you get an insoluble substance, right? So precipitation means that you are insoluble. And if we're talking about KSP here, then what we're talking about is the insoluble side is this side over here, the solid side. This guy over here is the dissolved side or the soluble side over here. So the insoluble solid side is on the left and the soluble dissolved side is on the right. So basically what we're going to be doing is we're going to be looking to see if the conditions that are provided will send the reaction over here to the left-hand side. Now we have already dealt with a mechanism which will tell us which way the reaction will go, to the left or to the right, and that mechanism is Q. If you remember from back in the day, Q is a test case, and it tells us whether or not the system is at equilibrium. If Q happens to be equal to K, then boom, you are right at equilibrium. Now, it almost never does. So if Q is less than K, if you remember, then that means we are shifting over to the right-hand side because we want Q to be bigger. Because remember that Q and K are products over reactants. And so if Q is too small, then we've got to make the products bigger, which makes the reactants smaller. So again, if the products are going to get bigger, it's going to have to go to the right-hand side. So if Q is less than K, it's going to go to the right-hand side. That's what this guy here is talking about. And the right-hand side for the KSP equations is always the dissolved side, the soluble side. But what happens if Q is greater than K? Well, if Q is greater than K, then here's what happens. If Q is too big, then you're going to have to try to make Q smaller. So the products have to go down or the reactants have to go up. And if the products are going to go down and the reactants are going to go up, the reaction is going to shift over to the left-hand side because Q is too big. And remember that for KSP, the left-hand side over here is always the insoluble side, so that is where the PPT, or the insoluble, is. So for these particular types of problems, it's very, very simple. They're going to ask you whether or not a precipitate will form. So will a PPT form? They are asking you in code, will the insoluble side win, so to speak, right? Or will the reaction shift to the left-hand side, or to put it more technically, is Q greater than KSP? Because if Q is greater than KSP, yes, you will get a precipitate out of it. So all you are going to do is take a look at these situations. You are going to set up the problem exactly as we did before. And then you are going to check to see if Q is bigger than K. If it is, get yourself a precipitate. If it's not, then you don't. All right, so let's check this guy out. It says, will a precipitate form of barium carbonate from this kind of a situation? All right, well, once again, you do a little happy dance because we see that it's KSP. So if it's KSP, I don't have a choice in the matter. I'm going to take barium carbonate, and I'm going to break it into the barium ions and the carbonate ions. And my KSP then is going to be the barium times the carbonate. And they told me that the KSP has a value of 2.6 times 10 to the negative ninth. So no problem. I got an I, I got a C, and I got an E, and I kind of don't care about the solid. Except that in this case, please note that it says that the barium is 2 times 10 to the negative fifth, and the carbonate is 2 times 10 to the negative fourth. Well, this is different than what we have seen before. What we have seen before is only one of those substances is present. Now I've got both of those substances. So the question is are those numbers too big? Are those numbers too small? Are those numbers too just right? Well, we don't know. Now, I can't do K, because K is only for the equilibrium units down here. So what I'm going to have to do is I'm going to have to do Q. So remember that Q is a test case. So Q is going to be the same thing as K, the barium times the carbonate. And we're going to go ahead and put in the numbers. Sorry about that. I'm trying to hold that one off and I couldn't. 2 times 10 to the negative fifth. Goodness gracious, so sorry. So Q then is going to be 4 times 10 to the negative ninth if I plug in all of my numbers. So now what I do is I compare my Q and my K. So my Q is 4 times 10 to the negative ninth, and my K is 2.6 times 10 to the negative ninth. So Q is bigger than K. So if Q is too big, what does that mean? That means the reaction goes to the left. That's the precipitate side. So yes, this guy here gets a precipitate because Q is too big. And that's all you have to do. You have to take both of your initial amounts, plug them into your K equation, and go to town. Example 2. Will a precipitate form of magnesium fluoride from these conditions? All right, once again, we've got ourselves a KSP. So I've got to do this. Magnesium fluoride is going to break into the magnesium ion and the 2 fluoride ions. The KSP then is going to be the magnesium times the fluoride squared. And that has a value of 5.2 times 10 to the negative 11th. I got an I and a C and an E, and I don't care about any of this because, again, it's a KSP problem. So all KSP problems are done the exact same way as far as the setup is concerned. Now what happened is they told us this is 4 times 10 to the negative 4th, and this is 2 times 10 to the negative 3rd here. Now you might say to yourself, but Smith, hey, there's a 2 there. So don't I have to take this 2 times 10 to the negative 3rd and double it? No, you do not. You don't want to do that at all. That 2 is only taken into account here and here in the change line. And we're not going to deal with the change line, right? We're not going to look into the change line. All we're doing is looking into the initial conditions here. So that 2 is going to be, plus x or plus 2x, or quite frankly, if it were to go the other way, it would be a minus x and a minus 2x if it were to go this way. But we're not getting there. All we want to do is see which way the direction is going to go. So consequently, we are not going to deal with that 2 because they are telling us what the numbers are. So don't make it harder on yourself. So what I'm going to do is I'm going to take these numbers and I'm going to plug them into a Q equation. So that's going to be 4 times 10 to the negative 4th times 2 times 10 to the negative 3rd squared. So I pick up my calculator and I do 2 times 10 to the negative 3rd times 2 times 10 to the negative 3rd times 4 times 10 to the negative 4th. So that's going to be 1.6 times 10 to the negative 9th. So my Q is 1.6 times 10 to the negative 9th. My K is 5.2 times 10 to the negative 11th. Q is bigger than K. So yes, indeedy, we get ourselves a precipitate because Q is too big. So now what's going to happen is that the reaction is going to go to the left-hand side, and this is going to go down by some amount x, and this is going to go down by some amount 2x, but we don't care about that because all that was asking about is will a precipitate form. Q is too big, so yes, a precipitate forms, and you're done with the problem. Last one, example 3 here. Will a precipitate of silver chromate form under these conditions? So once again, I've got a KSP equation here. So I'm going to set it up like I normally would. Ag2CrO4 is going to break into 2 silver plus 1s. So 2 silver plus 1s and a chromate. So that KSP is equal to the silver squared times the chromate. And they told me it was 9 times 10 to the negative 12th. I got an I, I got a C, and I got an E. I don't care about this because remember, that's a solid. It's telling me what the silver is, so don't get cute. Just put the number in. That's the number for the silver. That's the number for the chromate. 3 times 10 to the negative 5th. Don't get cute. I can't put these numbers into K, but I can put them into Q. So I'm going to take those numbers, I'm going to put them into Q. So this is 2 times 10 to the negative 4th squared times 3 times 10 to the negative 5th. So 2 times 10 to the negative 4th times 2 times 10 to the negative 4th times 3 times 10 to the negative 5th gets me a value for Q of 1.2 times 10 to the negative 12th. So if Q is 1.2 times 10 to the negative 12th and KSP is 9 times 10 to the negative 12th, Q is too small, right? So if Q is too small, then that means that there will be no precipitate that will be formed there. No precipitate out of this guy because Q is too small. And that's it. That's everything for the unit. So in these particular precipitation type problems, all you're doing is looking to see if Q is greater than or less than K. If Q is greater than K, it'll shift to the left, and that will give you a precipitate. If Q is less than K, it'll shift to the right, and you will get no precipitate out of it.